This is section 4.4. In this section, we're going to look at non-homogeneous linear equations. So if you recall from 4.2, when you have one of these equations that is not equal to 0, we refer to this function on the right, this f of t, as the non-homogeneity. Our method is going to be the method of undetermined coefficients. So that is, we're going to let y take the form of some linear equation with undetermined coefficients. So we'll just call them am, a2, a1, a0, and we'll solve for them later. So let's jump straight into an example. If we're given the second derivative of y with respect to t plus 4 times the first derivative of y with respect to t plus 2y is equal to 12t plus 7, well, it takes proper form. We have a second derivative, first derivative, an original equation, and it's equal to some function of t. So this is your non-homogeneity, your 12t plus 7. Our solution, we're just going to say the solution is a1t plus 0. We choose this linear because it has the same degree as f, the equation on the right, the non-homogeneity. If the non-homogeneity, say, were some cubic function, we would go with a 3t t cubed plus a 2 squared t, a2t squared plus a1t plus a0. But here, since it's just linear, we're just going to go with a linear equation. So we have y is equal to a1t plus a0. The derivative is just a1, and the second derivative is 0, so that's simple enough. We're going to plug this in and see how well it does at solving the equation. Well, the second derivative is just 0. First derivative is a1, and the original equation is a1t plus a0. Simplifying, we get 2a1t plus 4a1 plus a0. So we've got our things that are multiplied by t and our things that are not multiplied by anything. This is going to become two separate equations. We're going to set the t terms equal to each other. So 2a1 is equal to 12. And we're going to also set the constants equal to each other. 4a1 plus a0 is just going to be equal to 7. Solving these two equations, we get that a1 is equal to 6. And then we use that fact over here to solve that a0 is equal to negative 17. So we reach a nice, concise solution that y is equal to 6t minus 17. Next, we're going to solve the second derivative of y with respect to t plus first derivative of y with respect to t plus 11y is equal to cos of t. Now, cos of t isn't some linear equation like before, so we need to think about what the derivatives of cos of t are going to look like. Well, they're going to be sines and coses. So it's an educated guess to say that our y is going to be some linear combination of sines and coses. So y is equal to a1 sine t plus a0 cos t. Let's take some derivatives. The derivative of sine is cos, and the derivative of cos is negative sine. So it's rather easy to get our first and second order derivatives here. And now we're going to plug them in. So this, the second derivative, is what you're going to see right here. The first derivative will follow. And then finally, 11 times the original function. And cos t remains on the right. Now, we are going to separate the sines and the coses. So what's multiplied by sine? Negative a1, negative a0, and 11a1. So that's what you'll see here. And what's multiplied by cos? Well, negative a0, positive a1, plus 11a0. But then we're actually just going to move this cos over. So we get to put in a negative 1 as well. So that's what we see here. Now, this actually is two equations. We've got negative a1 minus a naught plus 11a1 needs to equal 0 because there are no sine t terms on the right. And the same thing goes for cos. Negative a naught plus a1 plus 11a naught minus 1 needs to equal 0 on the right. So we'll start on the left. 11a1 minus a1 gives us 10a1. 10a1 is equal to a naught. Now I'll move over here to the right side equation. We've got 11a naught minus a naught gives you 10a naught, plus a1 is equal to 1. Now we need to do a substitution. So for a naught, we're going to plug in what we know a naught is equal to, which is 10 times a1. So over here on the right, we have 10 times 10a1 plus a1 is equal to 1. Well, that's 101 a1 is equal to 1. And we get that a1 is equal to 1 over 101. And then we can finally plug that back in to this equation to get that a naught is equal to 10 over 101. And that's our final solution. Y is equal to 1 over 101 sine t plus 10 over 101 cos t. Now, we've been making some educated guesses so far. We haven't really had any rules to work with. Page 178 of the textbook is going to show a comprehensive list of the rules for using the method of undetermined coefficients. And it's going to talk about the two different types that we were looking at, where you have something kind of linear on the right, or if you have something to do with trig functions on the right. Sorry, polynomial or trig functions, is what I meant to say. So if you go to page 178, you can give that a read over. We're going to use that as a reference to work through the following sample problem. And after this problem, we're going to be done today's video. But in general, the way to go through problems in this chapter is to always look back to that page 178 explanation, and it will guide you through how to do any given problem. So here we have 3y double prime plus y prime minus 4y is equal to 2t squared e to the 3t. So the first thing we're going to do is check the auxiliary equation. And the reason for that is on page 178, it gives you specific rules depending on if the auxiliary equation has 2 unique roots, a single double root, or no real roots. Now, when we expand this, we're looking for something that multiplies to give you 3 times 4 and adds to give you positive 1. Well, that's going to be negative 3 and positive 4. They multiply to give you negative 12, and they add to give you positive 1. So that's how we factorize this. Again, your method of factorization is not important. So we solve as r is equal to negative 4 over 3 or 1. That's 2 unique solutions. And also, we were checking to determine whether 3 is a root of the auxiliary equation. Again, going back to page 178, it asks that you look for whether this r value is a root of your auxiliary equation. 3 is not a root of the auxiliary equation. So according to our rules on page 178, we're going to follow this form. Y is equal to t to the 0 times a2t squared plus a1t plus a naught times e to the 3t. Now, we're going to need a couple derivatives. Now, also, t0 will just fall off. That's just multiplying by 1. The first derivative is going to follow a product rule. The second derivative is where it might get a little more messy because it looks like we've got a couple of product rules to do. So you see it can't even all be contained in one line, but this is all our second derivative. And now we're going to evaluate. 3y double prime plus y prime minus 4y is equal to 2t squared e to the 3t. Well, we're going to plug in what we just solved for y double prime, y prime, and y. And it's going to make this very long expression. But you'll notice that 3 times y double prime, that is all of this here. And you can check to see if that is exactly what is written for y double prime. And then we add that to y prime, and then we subtract 4 times the original function y. Now, our next step is we're just going to simplify a little bit, dividing both the left and right side of this equation by e to the 3t. So when you divide out that common term, things do get a little bit nicer. Then we're just going to multiply through the brackets. So things like this 3 is going to expand onto every term. This 3 here will multiply through. This 10 here is going to multiply through. You're just going to multiply everything through. And then continue simplifying. Now we're going to break this into a couple different equations. We have the things that are multiplied by t squared. Then we have the things that are multiplied by t. And then we have the constants. So that's 3 different equations we're going to deal with. The first one, the things multiplied by t squared, we get 2 is equal to 29a2. So a2 is solved immediately as being 2 over 29. Now, as for the things multiplied by t, there's nothing multiplied by t in the left side of this equation. So 38a2 plus 37a1 is just going to be equal to 0. Scroll down. We'll see that. But we already know what a2 is equal to. It's 2 over 29. So we can plug that in. And we get a1 is equal to negative 76 over, not even going to figure out what 29 times 37 is equal to. It's not necessary right now. And now a0, we're going to solve using our third equation, which is 6 times a2 plus 19 times a1 plus 37 times a0 is equal to 0. And we'll just go back to explain again where that's coming from. It's all these constant terms on the right, but there are no constant terms on the left. So we know if we add up all those constant terms on the right, they actually have to just equal 0. We won't waste much time going over this algebra, but just finding common denominators. You can solve this and just figure out what number it is, but things aren't going to cancel out very nicely. It's just going to be a large number. And we get this final solution where this was our a2 value, I believe, being multiplied by t squared. Yep. There we go. a2 was multiplied by t squared, a1 multiplied by t, and a0 at the end. And that's what we get. There's our a2, there's our a1, and this whole thing was the a0. And don't forget to bring back that e to the 3t. And this is our final solution. I believe doing the questions in the textbook, you can look forward to some less complicated arithmetic. Hopefully, at least.